Hi, I'm Miranda Cosgrove, and this is Mission Unstoppable. Coming up, explorers and scientists and inventors, oh my.
What I love about our explorers is that their courage really comes from curiosity.
Then, shame can make you think the world is ending, but Dr. Brain lets us in on a little secret.
We can blame that feeling on our brain.
And find out what gets this adrenaline-seeking scientist on the move.
During the summer, whenever there are storms to chase, I definitely go every time I can.
Then, some scientists spend their careers in a lab, while others make their lab on the side of an active volcano.
So we should walk really quietly and try not to shake things up?
Yeah, don't disturb the volcano.
Get ready to meet the scientists, inventors, and heroes who help make our world a better place. The future is here. The Mission Unstoppable. Not every building can be filled with scientists and explorers. That's why we're doing a story on one that is. Take a look. For over 6 million years, ever since humans could walk, we've looked around our world, taken stock of the environment, and gone, I wonder what's over there. And that adventurous spirit is something Jill Tiefenthaler knows all about.
I was always really interested in math. I went off to college and I thought I would be a professor for the rest of my life. But when opportunity knocks, I think sometimes you just have to step into those difficult choices and try new things.
A main part of Jill's job here involves supporting a global community of National Geographic explorers, which includes scientists, conservationists, storytellers, and educators as they take their own risks. Like Denley Delaney, the senior manager of the Exploration Technology Lab, who oversees the development of boundary-pushing gear to aid explorers in the field.
So it must be fun to work with explorers.
There's a lot of extreme environments out there that really require custom pieces of tools and technologies. Being able to help explorers really go further and illuminate and protect the wonder of our world is really exciting.
The gear built here includes items like this drop cam, which can descend 20,000 feet below the ocean's surface to study the little explored deep sea.
We've deployed this almost 600 times. We've collected over 1,200 hours of footage, and because so little of the ocean has been explored, approximately 1 in every 10 deployments of our deep sea camera system results in some sort of scientifically publishable discovery.
They've also developed specialized cameras that can be attached to animals.
The Exploration Technology Lab has marine critter cams, which are animal-borne video tags that enable us to collect video data from the animal's perspective so that we can study their behavior.
And we've even put a camera on a shark, right?
That's correct. We've put a critter cam on a shark, and it's one of my favorite photos taken because it was on a tiger shark in the Bahamas, where I'm from.
In one afternoon, Jill can go from talking tech to discussing discoveries with explorers, like Rosa Vasquez Espinoza, a chemical biologist studying microorganisms in the Amazon.
So tell us more about Peru's boiling river.
There are unique microorganisms that have evolved over thousands and thousands of years to thrive and flourish in these extreme conditions. I think it really can teach us about, one, evolution of life in the Amazon, but two, provide us with new tools for medicine, biotechnology, and even how to better protect the jungle. And we want to use science to contribute to the knowledge that already exists and provide an additional layer of knowledge about it.
It's so amazing what you've done with science.
There is so much to do and so much to discover below our feet. It's such a critical point right now to protect our jungles, and I'm just hoping that with my work I can make a difference.
That desire to create change is what fuels Jill and her team, powering them towards the brink of the unknown, all in the hopes of building a world that we understand a little bit better.
In the end, what I love about our explorers is that they're taking risk, and their courage really comes from curiosity. They want to learn about the world. They want to push the boundaries of exploration, of knowledge on behalf of our planet. So, when that risk comes from being curious and about learning, I think it really is worth taking.
On a scale of 1 to science, this next segment is on there, but in a good way. That rating system is still in development, and we're trying to fix it.
Spinach in your teeth on a date. Waving at someone you think is your friend, and then it's not your friend. Sending a text about someone to the person that you're talking about. When we get into these situations, we feel embarrassment, and we can blame that feeling on our brain. Hello, I'm Dr. Brain. Okay, my real name is Crystal Dilworth, but I have a PhD in neuroscience, so it's just easier to call me Dr. Brain. So, I'm Dr. Brain. True embarrassment has two parts. The first part is the catalyzing event. This could be a physical mistake, like playing sports and dropping an easy catch. Or it could be a cognitive shortcoming, like answering a question incorrectly, or not being in the know about a piece of information or gossip. The second part of embarrassment is the public nature of the catalyzing event. To be embarrassed, you need an audience. After all, it's not embarrassing if no one else knows. Embarrassment is a full body and brain experience. Both excrete the stress hormone adrenaline, triggering the body's stress response. Yeah, the same adrenaline that your body makes when it's in actual danger, like if you're confronted by a bear. Ugh. Terrifying. As a result, we experience accelerated breathing and an increased heart rate that causes blood to rush through our body, getting us ready to fight, freeze, or flee. You know that expression of embarrassment, that classic blushed cheeks? That's because of that blood rush. Sweating is also a behavioral symptom of the body's stress response. One of the interesting things about embarrassment is that the audience doesn't always have to agree that what happened is embarrassing. Sometimes it's not the actual opinion of others that causes embarrassment, but it's our own idea about what is acceptable and what others might think. Which is great, because it gives us power over our own embarrassment. We are human, and humans make mistakes and do foolish things in front of other people. But there are ways to combat the bad feelings that result after an embarrassing event. Take a deep breath, try to calm your heart rate, and ask yourself, hey, self, do you believe that what we did is as bad as others think? No, and actually, maybe they're not judging us at all. Also, if you see someone doing something embarrassing, help them. Try to deploy empathy with their situation. You can help take away that awful feeling of fear and embarrassment by reminding them that their mistake or failure doesn't change their value as a person. Let them know that they're still accepted and appreciated by you and their peers. Who knows? The next person to embarrass themselves in public might very well be you. So give yourself a break, people. Being embarrassed is part of being human. To my non-humans, however, like my pet cat Herman, you should be embarrassed. I saw you chewing on my phone charger. It's not a snack, man. Okay, bye.
Balloons are a key part of being a birthday clown, and also for predicting storms. It's weird that there's any overlap, right? Let's see what those weather balloons are up to.
Some people come to college seeking wisdom. Some people come to college seeking love. And some people come to college to storm chase. Today, I'm at the College of Engineering and Mines to meet one of these storm chasers, meteorology graduate student Lexi Elizalde.
So whenever I was little in elementary school, my town had a convention for severe weather and storm chasers. And my parents were like, you know what? She loves weather. Let's take her. It absolutely fueled my passion and made me want to become a meteorologist.
Today, Lexi is going to tell us about storm chasing and how to measure atmospheric condition with weather balloons.
Walk me through the process of storm chasing.
So I'm still technically going to school, but during the summer, whenever there are storms to chase, I definitely go every time I can. I start forecasting a few days out, looking at models, and as it gets a little bit closer, then I start to look at actual observations around the area. Then whenever the day comes, if it's looking good still, then I'm like, all right, let's pack up and let's go.
What's your next step? What do you do then?
I take pictures, and I always stay out ahead of the storms. I never get into the storms. I actually never even get a drop of rain on my car, typically.
So safety is a really important part of your job.
It's #1 priority.
Meteorologists around the world make their forecasts with the help of weather balloons, and almost 900 are released every single day. Lexi is launching a balloon this afternoon with help from fellow grad students Jake and Sam, advisor Dr. Claybo, and me.
So here we have the balloon itself, and it is attached to a parachute. which is attached to some more string, and then attached to a radiosonde that we have there at the end, and that's what we call a train.
So it goes up and it comes back down.
As the balloon pops, as it gets higher up in the atmosphere, it doesn't just fall straight down onto somebody or somebody's car. It has a parachute attached, so it'll safely fall down.
What do we have with the radiosonde?
As it goes through the atmosphere, it measures pressure, temperature, relative humidity, wind speed, all sorts of things.
So ultimately, what are we testing for?
So the thing you might not know about storms is that they actually build vertically. We need to see exactly what's going on as it goes up through the atmosphere that would lead to these storms potentially getting going and building and sustaining themselves.
What are the steps for a storm building?
So we need to have 3 ingredients, which is instability, lift, and moisture. For instability, we need to make sure that the storm stays warmer than its surroundings. For lift, we need some sort of mechanism, whether it's winds forcing it up or a front or even mountains, to keep it going up into the atmosphere. And then we also need moisture.
Before the balloon can take off, we need to fill it with helium. A lot of helium.
It is so big. This is amazing.
So the pressure is much more down here and far less in the atmosphere. So as it goes higher into the atmosphere, it will actually expand to 3 times the size.
It gets even bigger.
It's even bigger.
Wow, look at that.
Yeah. All right, high fives, everybody.
High fives.
With the balloon in the air, Lexi can start looking at the data on her laptop. The radiosonde transmits wirelessly to this receiver, allowing her to measure temperature, pressure, dew point, and more, all the way from the surface to sometimes 100,000 feet in the air.
How do we use the information that we found out about today's weather for the future?
The Weather Service actually collects it twice a day, and other scientists also release their own weather balloons depending on their location. Weather impacts our daily lives and everything that we do, playing softball games or sports, going fishing, growing crops, even planes taking off. They need to know the most up-to-date and accurate weather as possible.
Lexi, this was so much fun. Thank you for showing me your work. I don't know if I'm tough enough for storm chasing, but do they have like drizzle chasers? Because I think I could do that.
Just be safe.
I will. Bye.
Hawaii is a paradise of beautiful rainforests, pristine beaches, and gas emissions. Wait, what? We sent Marina to find out what's up with those.
I'm here at Kilauea, a volcano that emerged from the ocean over 100,000 years ago. And while it isn't always erupting, it is always emitting volcanic gases. Today, I'm meeting with Patricia Nadeau, a volcanologist who can tell me exactly what those gases mean.
So I started my career as a volcanologist in college by majoring in geology. Took a lot of different geology classes, and volcanology was my favorite one. There's not all that many people who study volcanic gases, but I was interested in it, so that's how I ended up here.
Here is the scenic Hawaii Volcanoes National Park, where Tricia and her team use specific tools to analyze volcanic gases and temperatures, which can alert them to the growing volcanic activity, signaling possible trouble in paradise.
So how hot does it get down there?
So we actually have a tool that tells us exactly that. So I can take this, which is called a thermocouple, can unroll it and stick it down what's called our fumarole here, and it will tell us exactly how hot it is where we're sampling those gases. It's kind of like taking a blood sample. You analyze your blood chemistry, we're analyzing this.
So you're analyzing what the volcano is putting out.
Once we get our sample, we send it off to our colleagues in the chemistry lab, and they can tell us, after they analyze it, how much of what gases is in the sample.
And as Tricia tells me, magma has a number of gases, including water vapor, carbon dioxide, and sulfur gases. Magma is the melted or molten rock under the Earth's surface. At all volcanoes, the pressure from these gas bubbles drives magma up to the surface to cause eruptions. And really high gas pressure can mean an explosive eruption, similar to what happens when you shake up a soda in a bottle and the gas wants to escape.
So we should walk really quietly and try not to shake things up?
Yeah, don't disturb the volcano.
So now that we know the proportions of the gas, how do we know the volume?
To get at the volume, or what's known as the emission rate of the gases, we have a completely different technique, and I can actually show you that.
Great, let's go.
These techniques help Tricia and other volcano doctors diagnose what's going on with volcanoes so they can understand the hazards better in order to warn the public, stat.
we have a car here, but how do you use a car to measure the volume of gas coming out of a volcano?
The car is just going to get me there. I'm actually going to be using what's called a differential optical absorption spectrometer, which is what all of this is part of. The less ultraviolet light that we measure, that means there's more sulfur dioxide above the car.
So basically you go from one side of the volcano to the other, measuring sulfur dioxide, and whatever's in between, that's from the volcano.
Exactly. There's not really sulfur dioxide in background atmosphere, so if you're near a volcano and you're measuring sulfur dioxide, it's a pretty good bet that it's from the volcano.
And if there's a lot, does that mean the volcano is becoming more active?
Yeah, it usually is a pretty good correlation. More gas, more lava, more volcano activity.
So you take the car out, you drive over the volcano, but how close can you get?
With the car, I stay on the road. Sometimes I'll fly a drone in to either take videos or get gas samples. So the drone allows us to get measurements and images where we can't go.
So you do chemistry, you do math, you're a drone pilot.
Yep.
You're a triple threat, you do everything.
Anything to understand the volcano better.
Okay, so I'm ready to go. I call shotgun.
Unfortunately, no. So where the volcanic gases go, it can be sometimes in dangerous levels. So the road is closed to the public. I can go down there because I'm a volcanologist, but unfortunately, I can't bring you.
If I get a PhD, can I come?
In volcanology, sure.
This has been so fun. Thank you so much for taking me around today and showing me all of this. I'll never look at volcanoes the same way. This is so interesting.
Thanks for coming.
Bye.
Bye.
Wait, I want to touch the plume. Dang it. Find my own plume.
And now it's time for, oh, wait, let me animate myself. Science Minute with Miranda Cosgrove. That's me.
Ugh, my text isn't going through. I hate it when that happens. It's probably because the radio waves my phone emits aren't getting to the cell tower they need in order to get routed through the network. And that's happening for one of 3 reasons. The first is that I'm too far away from the tower. When radio waves have to travel super long distances, they can get so diffused that they peter out before they reach their destination. The second is that my waves get blocked before they ever even reach the tower. While radio waves can travel through most things, they have a hard time passing through thick layers of dense materials or even thin sheets of certain metals. And finally, my waves might reach the tower, but they don't get processed because the network is overwhelmed by more messages than it can handle. That can happen when everyone's trying to call or send a text at once, like during an emergency. This isn't an emergency, but it certainly feels like one.
Welcome back. Before we go, we have one last thing.
There's gonna be so many times where you're told no, you're gonna get through it, you're gonna work hard, you're gonna be there eventually. It's just you gotta get through the bumps in the road.
Finding and developing that passion really is taking those chances, stepping outside your comfort zone. Sometimes the route to get to where we want to be is not a straight line, right? It's very circuitous.
Whatever you like, there's probably a way to relate STEM to it, and someone has to do it, so it might as well be you.
That's it for this week's Mission Unstoppable. Maybe next time we'll let some scientists just vibe. Have the scientists take a day off from changing the world. Relax a little. They've earned it, you know? Bye. If you're watching this, you must have really liked the video. Make sure you follow and subscribe, and check out these other videos that are even better. No, really. I've seen this one over 100 times.